This may be a bit of a long video, but it'll take us all the way from our original x and y values through the creations of a linear and exponential model, including with some transformations. First up, we've got a linear model. You can see I've got spaces down here for A and B. Those are the A and B associated with our general linear model, where y equals A plus B times x. So B is our slope, A is our y-intercept. We can look at this and try to figure out what the slope and y-intercept should be for that line, and then go about moving things so that that line's going through roughly these blue dots. Or we can get a better idea by right-clicking on there, adding a trend line, linear trend line, then we'll display the equation on the chart. This equation is the most mathematically accurate trend line possible. Okay? This does not necessarily mean that it's going to be the best model for your data. This is where you can use your knowledge of the subject matter to take this line and shift it up, down, left, right, maybe cancel a little bit more so its slope is a little bit greater or less than what it's showing here. And that's where you use your knowledge of the subject matter. But our starting A and B values, according to this, are going to be negative 21.028 for the y-intercept, and the starting slope that we'll use will be that 4.8023. Okay. Then I'll come up here and create this linear model. We're going to calculate the new y values based on the original x values here. So our linear model has the form A plus B times x. A is right here in the cell C8. So we'll take that and add to it B, which is in C9. Times the original x value, which is right over here in A3. Notice I use the dollar signs when calculating with the A and B. That way, regardless of where I pull this formula to, I will always be using this A and this B value. And then A3 is always going to be the x value directly across from that corresponding model value. If I hit the go button and then drag this little green box all the way down, we get our model values. We could verify that 99 is pretty close to 102, 113 pretty close to 108, and so on. So these are fairly decent model values. Then we can go over here to our original curve and add in a series. This will be the linear model with the original x values and our model y values. Hit the go button a couple times and we can see those orange dots are directly on top of that blue trend line, as they should be. And we use this trend line, this equation, to come up with this model. So those orange dots should lie right on top of it. But again, this is where you can use your knowledge of the subject matter to say, maybe you know that this point up here, this highest point, is an outlier, and so that doesn't really affect, or shouldn't affect as greatly, our trend line. So we want this slope to be a little bit less. Instead of a slope of 4.8, let's make this a slope of 4. Notice I'm changing it over here in C9. When I hit enter, indeed everything else changes. So it shifted it down. By changing the slope to 4, decreasing the slope, it shifted everything down. So now I need to shift it back up. You can see this point here is roughly at 80, and we want to shift that up closer to 100. So I need to add about 20 here. Let's make this -1. If I hit enter, then indeed I've shifted everything up vertically. Now it looks like we need to shift it up a little bit more so that those orange dots are relatively on top and going through the blue dots. Notice too that this is a little bit better model if I'm assuming this is an outlier and not representative of my trend line, the true trend line for that data. This is all based on your knowledge of the subject matter. Maybe you know with your expertise that A should be 0, that our y-intercept for whatever this model is should be 0. Then you can go in here and set A to 0 and then change your B value in order to make those orange dots consistently go through our blue dots. Either way, we could change the A and B values here to make better and better models for that data using our knowledge of the subject matter. So notice, I'm not just using the linear model that was given to us by Excel, but rather coming up with our own. So here, we can write down this final, if we assume that this is our best possible model, we can write down this final linear model to be y equals 0 plus 4x. Okay? Likely with your data, you're going to have decimals and things like that, not the nice pretty whole numbers like this, but this would be what we'd write down for that final linear model. Now for the exponential model, we'll work through the same process, but the first thing I want to note is that with an exponential model in general, we're going to have an A value that represents where it crosses the y-axis. In this case, it may or may not be representative. Excuse me, let me run it here. For the purposes of this, we'll go ahead and uncheck the linear model so that we can only see the blue dots, just to clear things up a little bit so we can work on that exponential. With an exponential model, the A value is where it crosses the y-axis, and then it's going to increase rather dramatically. So this is going to be concave up and increasing if we're applying an exponential model to it. But we see that if it's going to increase dramatically after this, it's probably quite a ways from that y-axis. So what we're going to do is shift this. Really, I'm going to shift all of these data points down and to the left. There's several reasons for this. Maybe in your problem, you know that this value should not start at 100, but rather should start around 20. Okay? Maybe we're just going to shift it to the left so that we've got an initial value of 100, roughly, which is what we would expect. Let's just do that, actually. So what I'm going to do, I'm shifting all of these units, all these dots to the left. That is, I'm changing the x values. I'm going to subtract, looks like 25 from those x values, and I'll list that here. So x minus 25. These are going to be the new x values, so this is going to equal our original x value, x minus 25, and we'll carry that on down for all the other x values. Okay, so this is going to shift all those blue dots to the left so that we've got a more accurate, likely more accurate representation for that exponential model. Okay. Now I'm going to push this original to the side, and we're going to graph just these new x values, our shifted x values, with the original y values. If you had to shift the y values, I'd go ahead and throw those right here. We're not doing that. In fact, let's just go ahead and copy these down for the blue dots, just so everything is next to each other. So we're going to graph our transformed data. If we were shifting the y values down, we'd be subtracting values from it here. Insert a new scatter plot. You can see it does look a little bit different than our original, mostly because the original is going all the way from 0 out to 40, and over here we're going from 0 out to 10. Okay, but they're the same width physically. So they do look a little bit different. We can still apply our exponential model to this. These are our transformed data points. In order to come up with an exponential model, we want to graph the line x versus log y.